All right, forming. This has been a long time coming. Here you go. Um, Beyond the basics, of course, we're going to kind of break this down into two things. That's going to be the bulk deformation or bulk forming. That's big chunks of material, mostly metal. That's what we're talking about today. And then there's sheet forming, sheet metal. You're hopefully familiar with some of those operations. The things we're going to be talking about kind of fall into these categories here. I'm not going to read through this list. Also for the sheet forming, there's a few that that we're going to be using. I'd like to kind of start off talking about the materials themselves, or kind of the general methods that you can do this hot, or you can do it cold. Okay, now sheet metal is always going to be cold, but for the bulk, sometimes it's better to do cold, sometimes it's better to do hot, right? So there's advantages, disadvantages, and I'll point out some of those. Well, I should say this really does mean hot and cold. If it's hot rolled, that means you're doing all the processing with the material above its recrystallization temperature. Okay. For cold rolled, it can still be hot, but it's still going to be below, but it's going to be below the recrystallization temperature of the material. Okay. Just to eyeball it, you can spot this just by looking. Now, the cold roll is going to be more smooth, and it's going to have sharp edges, right? If you look right here, compared to right here, you'll see that this kind of bows out a little bit. That comes from the actual processing, that it's softer, it's squeezer. You squeeze it and it deforms. So what that also means is that your dimensions are going to be a little bit off um, there too, which makes this hot rolled uh, less expensive and less valuable, I guess, in both regards. The one thing about the cold rolled that you'll notice is that it's going to be oily when you get it, and that's because, man, friction is such a big thing. It's takes really extreme pressures. It's hard enough if you heat this thing up so it gets soft, um, but with the cold rolled, it is such an intensely physical process. The machinery is going to be much bigger, much more expensive. Friction is going to be a much bigger thing, and so you'll find that these surfaces are going to be oily because they just load this down with oil as a way to reduce the friction and save on the amount um, of power that they're having to expend. Okay, so advantages, disadvantage, right? Cold working, there's no heating required, and you get a better surface finish. Okay, but if you're concerned about the deformation forces, meaning, i.e., the expense of the equipment that you're going to have to use, hot working is going to be much less expensive equipment because it requires lower deformation forces. Also, you end up with no residual stresses because you're going to have the opportunity for the material, once you deform it, to just relax, and the crystals, the grains are going to kind of reform and remove any residual stresses, meaning that there's not going to be any change in material properties. However, if you do want there to be a change in material properties, for example, the increased yield strength, you want something that is already kind of pre-hardened, then that's what cold working does. And in that case, if that's your interest, then that would be an advantage in that regard. Okay. Let me talk a little bit here about the grain structure. Here on the left, this cast grain. So we've seen these pictures over here. Chill zone, equiac zone, columnar zone. You're familiar with this. When we talk though about the formed material, whether it's rolled or forged or what have you, then as you're making it, it actually deforms the grains in a favorable way. So look at this. You can kind of see these little patterns here where the material looks like has obviously gone through some kind of a flow, right? And so that's exactly what happens, is that you take the grains and you're going to stretch them, compress them, and squeeze them out, and do a lot of these things. And now, if it's cold worked, they're going to stay like that pretty much. And so you're going to have these, stressed grains all within your material. If it's hot worked, then those grains will restructure themselves, and then you won't have any stresses in the material remaining, and your grains will be, the standard kind of roundish or symmetric. But there is one thing. So take a look at this. So you see these lines here. That's actually not the grains. That is what you're seeing there is the impurities, and that makes a really big difference. It actually makes a positive difference. that then I'll show you down here. So look at this picture down. Look down here. So if you've got a cast material and then you do some machining, what you end up with are here. Let's see. I'm looking where these black lines hit the edge. There's one. There's one. There's one. There's one. There's one. Right. So if you were to zoom in, what you would see is there's the metal. Oh no, a little bit of an impurity. The metal. Oh, a little bit of impurity. Metal, a little bit of impurity. And so, what do you think is going to happen when you begin to stress this? Yeah, well, I mean, I didn't hear you, but I'm assuming that you said, well, that's going to be a problem. These are going to be stress concentrations at these areas. And these are actually uh, uh, points where cracks can propagate and cause trouble. Okay. Whereas with the rolled or other kind of formed process, because of this squeezing and reshaping, that it actually moves the impurities in kind of this flow path that stays whether the grains recrystallize or not, hot or cold. And you have a much, much lower incidence of the impurities uh, hitting tangent to the surface, right? Tangent to the surface. So, you know, it's kind of, something like that. Every now and then you'll have something come out, but for the most part, the outer surface is going to have fewer exposed kind of, you can think of it as fault lines, or potential sources of crack propagation. Now, the material properties aren't necessarily changed depending on if it's hot or cold rolled, but all we're doing here with this forming process is we're squeezing around the impurities in such a way that it will help the 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 robustness of this product. Okay, and so you'll find that things that are very critical, if you're a rally car or pilot, that there's going to be parts of your machines that are going to be very important that they don't break or shatter, and so you'll find often that those parts are going to be formed rather than machined. So there's different types of forming. Rolling's one of them, and I'll talk about that. You imagine you've got these two rollers. You're going around and around, kind of in opposite directions, and you've got this material that's going to be coming in from this direction. The rollers are a little bit tighter, so as the stock goes in, it's going to get squished right here. And so these grains that you see are going to be stretched. They're going to be compressed and they're going to be elongated. Now, if this is a cold rolling process, then they're going to stay that way, flat and elongated. What I mean by that, flat and elongated like this, right? Whereas if this is a hot working, shortly after it comes through, then the grains will begin to recrystallize and you'll again form kind of your original grain size and shape, which again will restore the original properties. But this idea of I said rolling, right? Because you've got these rolls, and so you're applying rolls to it. So that would be a rolling process. You apply a hammer to something, that would be a hammering process. Okay, that's where the word rolling comes from. Is that we're not rolling the material, but we're using rolls or rollers to affect the geometry. Okay, let's see if I can get this video to play. I'm not going to show you kind of the whole thing. It's a couple minutes long, and I think there's not audio, so I'm just kind of doing the voiceover. Let me navigate to the parts here that's going to be important. Okay, this is an example of the hot working. Okay, so this is just kind of an oven. You've got the chunks of material that are entered in, and then they're heated up, and then they're processed. Okay, and this rolling, it can be, two rolls opposite. You can have rolls with shapes on them or features rather than just flat. And as you pass this material through these rollers, then you're going to be inducing not a ton, but a little bit at a time, a little bit of shape change, a little bit of shape change, which is why you're going to see that, often these are going to have multiple passes, right? So here's an example. right? So this example where you're, moving one kind of back and forth through different processes. Here's a real life video of that. It comes through one roll, turns, now it kicks and goes back through the other. And again, it's going to go back and forth kind of through this sequence until it comes out in the desirable geometry. This can get a little bit complicated. Here's an interesting one. So it goes through, and then you have these kind of different stacks of rolls, and you can pass it one way through the other, and you can do some real interesting processing there. Okay, it doesn't just have to be in 2 dimensions, as you see right here. That you can be applying these stresses or applying these deformations, the squeezing, kind of in all directions. But again, these are done with rollers. And that's how that process works. Okay. There's another kind of interesting derivative of this. It's called ring rolling. Ring rolling, and I'll just show you. I got a quick video so you can see how this works. It's really clever. You start with something small with a small hole, and you end up with something big with a big hole. Okay, so imagine this is kind of like a disc, right? So or donut shape. So you start off. Let's see here. Come on, there you go. So start off, think about it just like a donut with a hole in the middle, and then you kind of come at it from all these different directions, right? Look at the left, how there's a roller that's kind of pushing against that side. Look on the right, on the kind of the top right, you see that kind of cone-shaped piece that's up there? That's going to be pinching it down. And so there's a shaft in the middle. And so what's happening is the shaft in the middle is forcing this thing to the left against this other roller that you see. And so it's squeezing that smaller and smaller and smaller and smaller. And so because it's getting smaller, it's trying to expand somewhere. Okay, it's trying to expand up. It can't because those conical rollers are pushing against it, and so it's actually expanding in diameter. And so, through this process, you end up here. I'll fast forward this. You can end up with some. So this is a big thing. So again, this was just that little donut of metal, and now you've got a really sizable, very precise, big metal hoop, and it's kind of cool. Now that's ring rolling. That's a special case, that you really can't do in any other way as far as manufacturing this. I mean, that's big. Do you see that guy right there? This is a big part. This isn't like a little wedding ring type thing. Ring rolling. Here's another one. So hammer forging, right? That's what I want you to hear. Hammer forging. Okay. So you got a hammer and you're banging. Okay. If you watch those shows where they make swords or you know kind of like primitive stuff, then that's forging, right? Blacksmith hitting stuff with a hammer, that's forging. Okay. So hammer forging. But you've got this drop forging, okay, drop hammer forging. Begin to automate this where you've got some hammer that just drops, and then does that. And then impression die, okay, impression die, drop hammer forging. And so now take a look at this right here. I'll draw my arrow. Okay, this is your die. You've got 2 pieces. You've got this piece, which is attached to the hammer. Okay, that's the piece that goes up and down, and it pounds the metal or the raw hot metal normally, which is just kind of draped over these areas. And as it pounds it with these dies, these impression dies, then it's going to begin to shape it. Okay, I'm going to come back to this picture. I just want to show you an example of this video here. Okay, I just want you to get a sense of how this drop hammer business works. Okay, this big piece up here is the hammer, and they're just holding the metal, pound, pound, pound. Okay, and then you just change it around, you move it, and you can adjust things. And what you end up with is this, very precise design. Okay. That's just pounding. You're gonna see a lot of pounding if you watch this whole video. But here's what I want you to note when we look back here. Look at this. 1, 2, 3, 4. Okay, so the first thing you do is you take your bar stock and you just kind of lay it across. You just lay it across this little notch that you see right there, and you pound, pound, pound again with the other side of that, and what you end up with is a kind of broken off piece that looks just like that. Okay, number one, right? Then you'll take this piece and you'll lay it over here into this area, okay? And you'll pound it, pound it, pound it with its opposite, and you end up with something that looks like that. Okay, so this is the piece that kind of lays in there. Okay, and then so that's the second step is you get a piece that looks like this. Okay, and then the third one, you can see where I'm going here. So for the third one, it comes in here, pound, 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 right? Then you end up with this, and then you do it on this fourth one here, and that gives you kind of the finishing touches there. And so this is the impression die, because that's what you're banging it with, and it's a drop hammer forging because that's the process of it, applying this force. Now that was the impression die. Drop hammer forging. Now here's another, I'm not going to show you this whole thing. This is open die drop hammer forging, and you'll be able to see that this is different. It's it's open, right? So this might be a way they started to make the blank for the ring rolling. And so rather than taking before the hot metal and cramming it, pounding it into this die, you've actually got now the die is not the hammer, but it's that little cylinder thing that they're just placing on the top and pounding into it. And that's what, and that's kind of the opposite way, or this is the open die that we see here. Okay, and you just keep on going. It's that's the process. Okay, upset forging is another category. You can see that here. This is a quick video. Again, hot stock, you pull this in. So upset forging, this is where you're actually able to expand rather than to decrease the diameter or the size of certain things. And you saw they just grabbed it and kind of squished it or pounded it, and then in one shot you're able to do that. I'll show you one more time here. You insert it and then you grip it right there tightly, and then you're going to bring in the die and then just pound it in one pop, and now you've got that shape that you're going to need. So the upset in the upset forging refers to the fact that you're increasing the diameter, increasing the sizes rather than decreasing them. Orbital forging is another alternative. This is there's a lot of wobbling here, so I'm not gonna show you this whole video. I'm gonna kind of move this forward to a spot where you can really see how this is happening here. Look at that. Do you see how that piece is just slowing down and it stops? Okay. So this is what's happening with the orbital forging. So you've got your die, but you don't come down on it and pound on it. It's like you come down on it and you just kind of grind on it or smear on it, like a mortar and pestle, or what would that be like, where you just come down and you're circularly, you're grinding on it, and you just kind of go around and around in a circle, and it's that kind of cyclic force that causes this to do. And you can see that it just kind of smears it down over time. Now it's not spinning. Spinning would be really high friction. What it's doing is it's actually just wobbling. Overall, forging works. You end up with some pretty high quality parts. One of the things that you'll notice on all of these is the surface finish, right? You remember how when we were talking about the sand casting, how you'd look at it and it would kind of look like it was sand cast, just because of the texture. And the same thing is here with the forging, that you can look at it and you can see the a certain roughness or a certain sheen on there, and that's typical. Okay, but these are good. Like these are good quality. You know, very high precision. On some of these, you'll see, you know, the parting line, right? Well, it looks like a parting line when we were talking about the casting. Okay, that's actually not the fact that you got two things coming apart. So you'll when you the impression die drop hammer forging, right? You'll end up with that kind of flashing, or as they call it, around the edges, that little thin stuff, and then you'll go back and you'll cut that off, and that's where you'll end up with you know, with these little lines. They look like, there you go. There's more flashing that you can see kind of around here. Uh, you know, looks a lot like what we saw with the other extrusion. This is another forming. This is another forming process. This is cool. Extrusions good. Around Ruston, there's a number of facilities that do this full time. I'll kind of describe this briefly, and then I'll show you a video. So this it's just a cylinder of material, right? It's not super hot, but it's just some material, and you heat up a little bit. But this is often a cold extrusion process. Put in here, and then you got this ram that just comes in, and you know, think of like Play-Doh back when you were, you know, 5. I don't know what age people play Play-Doh. Come in with a ram and you pound it, and you're essentially squeezing it out this hole, and so you end up with something that is going to be long and skinny. Okay, and so you got the die right here. Uh, right here, that's the orifice, whereas this whole thing here is the die that is going to be what determines the shape of what comes out. Okay. The cool thing about extrusion, you know, you'd think when you look at this, you'd say, well, how in the world would you ever produce anything hollow? You know, but there's a lot. You know, certainly there's pipe, but there's tubes, right? Big thing in what's that, toward Arcadia, Hayes, they do tubing. And so this is something I want to kind of point out. Just I'm not going to ask you a question about this. This is just kind of interesting. How do you do extrusion in a way that you can make it hollow? And I'll show you. And it has to do with the ram, right? So the ram back here, and in all these pictures, that's the ram. That you've got this mandrel that goes from the ram and then out. Okay, it goes from the ram then out. So there's two kinds. There's the kind that will move in and out. So in this case, with the dotted lines. So um, this is a long mandrel, and it moves in and out of the ram. Okay, and so you push this in, and then uh, you know, it comes out here, and then so when you begin to do the extrusion, you know, so poke a hole first in the material. Then when you begin to do the extrusion, it will be extruded kind of around this. Okay, and so here you're holding the mandrel still and then moving the ram. Over here on the left-hand side, you're holding the ram still and you're moving the mandrel. Okay, and this is kind of in two separate processes. An alternate way would be to combine the ram and the mandrel into one piece. Okay, makes it a little bit easier on the setup. What you end up with, though, right here is a little bit of stuff that you can't really use. Okay, so what first comes out is going to be kind of plugged by this mandrel, but once the mandrel, you know, so this is the mandrel's moved out a lot, right? So once the mandrel is moved out, you know, a little bit beyond the orifice, then everything behind that's coming out is going to be cylindrical, is going to be tubular. Okay. The reason why this works is the flow rate, right? So if you've got a certain diameter right here, okay, and you've got a certain diameter inner and outer right here, when you think about the conservation of mass, you're going to find that, okay, that this ram might move, you know, 1 inch, and this tubing might extend out 60 feet or more. And that's because you've got a huge volume of material, but what you're creating is just something that is a very, very thin-walled, small, low-volume thing, and so you're really making a whole lot of this tubing, and so this kind of mandrel ram combination works because of that. So up until now, we've talked about the forging, the rolling, extrusion. Okay, and we could consider those to be squeezing metal forming operations. Okay, there's non-squeezing that could fall into these categories: shearing, bending, and then drawing and stretching. I'm not going to go into detail on all of these. I'll just touch on a few, just so you can get an idea of how this works. Okay. First, I'd like to talk about kind of the combination. So we've got shearing. So this, what I'm about to say, relates to the shearing, piercing, blanking, fine blanking. That'd probably be good. Okay. And that is punch. Notice that there's not anything here called punching, but that's what we do with a lot of these. So we've got a punch, which works kind of like 1/2 of your scissors. And then the punch just comes down and it shears right here, and it cuts that off or shears that off, and now you've got your ultimate part. Notice that there is going to be a little bit of a clearance right here, and that's just to help their the deformation to be good, not put too much stresses here on the die. Okay, hopefully you're familiar with punching. 3-hole punch, right? It works that same way. We can put this punching operation in the category of piercing and blanking, and I think this diagram here kind of speaks for itself. The workpiece here, you're cutting out, in this instance, you're cutting out circular discs, okay, for subsequent operations, right? So that's going to be your workpiece. Whereas here, piercing, the object is just to cut out things, to make holes, or to remove some of the material from the workpiece. And so in this instance, what you're going to carry on to the next step, what you're going to eventually put a price tag on and try to sell, is going to be this material that you have pierced things out of. Whereas blanking, what you're interested in is getting these blanks, or in this case, getting these little discs to use for some future operation. Okay, spinning. This is an interesting one. Maybe I'll show you this little video and then come back to that and see. So this is always going to be axisymmetric. These parts that you'll make, right? There's the axis. There's the axis. It's going to be symmetric. You're going to, on this next little video, you're going to see a roller here move, and you've got this shape that's going to be spinning, and then you've got the sheet metal that you're going to hold and just essentially shape to that. Okay, this behind it is already spinning. Clamp in your sheet metal, get it spinning. Then you want to lube it up a little bit. And now with the roller, you are shaping the sheet metal to the mandrel, or to the die there that's right behind it. Now, this is important to remember where the friction is at here. Okay, the roller, the sheet metal, and that die right behind it, they're all spinning at the same, not at the same RPMs necessarily, but at the same, you could say capital V, right? That velocity. So there's not going to be any slippage between the roller and the sheet metal, no slippage between the sheet metal and that die in the back. And so it's kind of a low stress operation, and you end up with some really cool things. Again, it's got to be symmetric, and something that obviously that you can do with sheet metal. Yep, pretty cool, right? It's kind of specific. It's a little niche thing, but you'll see that a lot in HVAC operations, or stovepipe things. Okay. Another couple of things I'd like to talk about. You can actually combine some of these operations, right? So, for example, 5-station. This is a picture of progressive. So this is what I'm talking about. It's a progressive punch die set or process. Okay. We'll come back to this picture up here. I want you first to look at this and pay attention, and I think you'll be able to see what this is doing just from looking at this. Okay, so in your mind, I would like you to divide this something like this. Okay, maybe adjust this line a little bit. Okay, so process number one would be this, where it takes this blank piece and it, let's see, punches out a hole, cuts that out, right? And then number two, it takes that part and then it'll cut this out, cut that out, punch another hole. Okay, and then number three, it'll start to bend some of these things, right? Bend some parts and do a little bit more kind of clipping or cutting as needed. Right, number four, some more bending. Number five, some more bending, and then it finally shears it off of the piece. And so what you end up with is, in this case, a complex or really cool, intricate part that you're not having to put your hands on over and over and over. This isn't okay, I'm going to cut it now, hand it to this other fella, and he's going to do something to it, and he's going to hand it to somebody else. Okay, but this happens kind of all progressively. So I'm going to show you a video in just a moment, and what I want you to watch for are these small steps. Okay, so this is the piece of material, but as it moves through the machine, it moves in moves about that distance at a time. Okay, this is the final piece that we're going to make, this clip. It is not possible to make that clip just in one cut, bend, punch operation. Okay, so this is where we're going to use this progressive process. Can you see that there, where it's just taking small increments, right? It goes up, down, and then it's just moving a little bit forward each time, and it's each couple inches is doing one precise thing, kind of like an assembly line, and then it all comes out. You'll see here in just a moment one of those strips there like before. Let me fast forward here. All right, and so you can see those holes here at the edges kind of denote that. Kind of denote that the way that it steps, and it's bend, punch, bend, what have you. And then finally, after all those operations, you end up with the final part. Now this is a lot more than a 5-step, like that photo that I showed you on the last slide. It's pretty cool, huh? So that's totally hands off. You just put in the blank sheet metal on one side, and what pops out is a whole lot of these little clips. Okay. Now, what you saw there was kind of a stamp, the punch and die. You can also do that here, this kind of progressive operation, but more of like a rolling bending or a bending. That's kind of in series. Let me show you that. So think back to this. Think back to this slide. What you're going to see is a lot of different sets. So this is a roller, this is a roller, okay, this is a roller, this is a roller, this is a roller, this is a roller, okay. And so you can kind of look. So it starts off as a flat piece of metal, and then what comes out of these two rollers is like that shape, and then that shape goes into here, okay, and then what comes out of there comes into here. And you can kind of see how this goes, and what you end up with is a roll formed shape. But again, this is that same idea of progressive. Okay, and you're looking at now kind of the top of the two, and you can see a little bit of what's happening here. Yeah, you can see it start to bend and curl a little bit more with this set, a little bit more. Okay, again, this is a progressive operation, and then what kicks out, is the final shape, is the final part. Man, that's pretty cool, isn't it? It's stuff like that that makes me real excited to be a mechanical engineer. All right, there you go. Well, that was what I had for you today. I hope that you've got the quiz open with you now at the same time, and you're able to get to the end. Thank you very much.